Hey everyone, and welcome back to the Dev Manual. I'm so excited to talk about some advanced concepts of TypeScript today. In this video, I'll be giving you a brief introduction and we'll go over some practical examples as well. We'll take a look at concepts like conditional types, map types, union types, and many more. Learning these advanced types is crucial for any developer aiming to level up their coding skills and want to become more proficient with TypeScript. So, enough said, let's take a dive in. Alright, so let's start with union types. Union types let you combine certain types into one type. Let's see this in action. We have a type user ID here, which is a string. And as you might know from the real world, there may be cases where this user ID here can also be a number. And how can we tell the TypeScript compiler that this is not always a string? We can type in the pipe operator and simply type in the other type. So, and what we are doing here is that we are telling the TypeScript compiler that this type user ID can be either a string or a number. And to see this in action by using it, we can define a function getUserById, where we receive the actual ID that is of type user ID. And we are not returning anything right now, just putting in a simple console log right here by using template literals, fetching user with ID. And let's console log the ID. Great. So let's call this function with the valid parameters first. Okay, get user by ID first with a string 1, 2, 3. And as we can see here, no compiler errors because this input here is valid. Let's do the same with a number 1, 2, 3. And the compiler isn't complaining too, because we are telling TypeScript, okay, user ID can also be a number. If I remove this thing here, we receive our error because type number is not assignable to type string, which is correct. So let's revert this here. And now we want to put in something that is not valid. Let's say we have an object that holds an ID property, which is a number. And this is also complaining because, as you might have guessed, this object here is not defined above. So we could fix it potentially by putting in another type here. And as you can see here, this is also valid now. But we don't want to have this here in our example. One important note when you're using your union type as a function input. There may be cases inside your function, for example, where you have to treat this ID here differently based on its actual type. And this is always a great sign and a good practice in TypeScript by using type guards. And to use type guards, we can put in a simple if statement here. If type of ID is a string, then we can perform here our string operations. And for the other case, if the ID here is a number, we can make the same by using another if statement. If type of number, type of ID is a number, we can perform here our number operations. So you could also use an else statement here, but I'm not a big fan of else statement, to be honest. I want my code a little bit more to be declarative, and that's the reason why I'm using our if statement here, just for the ones of you who are curious. Okay, let's continue with intersection types. So they are pretty much the same as union types because they also let you combine certain types into one type. but this combination and the usage of those types behave a little bit differently. Let's take a look at our example right here. Let's imagine we have an e-commerce platform where we have normal users and some special users which are merchants. And in our code, we have defined those two interfaces right here. The one is for, let's say, normal users that hold a bunch of properties. And here is the interface for our merchant users, which have another two properties right here, like the merchant ID and the products. And now we define a certain function that prints out some information about our users. So let's call it read merchant info. And we pass in a merchant, which is the type any for now. We will come back to this later. And just simply logging out something. Okay, so we want to accomplish the following part. We would like to take in a merchant and then print out its name and its products. And as you can see here, the name property and the products property are at different places. So it is not enough to just pass in a user interface right here, because we have some access to the name property, but not to its products property, because this is inside the merchant interface. And this is also true for the other way. If we pass in the merchant interface here, we have some access to the products array, but not to its name property. And this is a great step where intersection types come into play. So we can define a new type above. Let's call it merchant user. And now we're leveraging the intersection operator, which is user and merchant. And now we are merging those properties from the user interface and those properties from the merchant interface together into one type. And now we can use this type here, the merchant user, as the merchant input inside our function. So let's first define the merchant to be a merchant user. And let's fill in our console log with merchant's name, which is merchant.name. And as you can see right here, the auto suggestion also works, which is always a great sign. And we want to have our merchant's products, which is basically merchant.products. And to make a little bit more cleaner our code here, I want to destructure the properties first from the merchant object. So let's pass in the merchant object and then extract our name and our products properties so that we can use it simply right here and not have to put merchant dot in front of this. And now we can finally call our function with the appropriate input. So let's first invoke our function here and pass in the following object, which is a valid merchant user type. And as you can see right here, we have all the properties from our user interface and all the properties of our merchant interface right here. And this is very important because you can't leave out something. If I leave out the merchant ID, the compiler is already complaining that the merchant ID is missing, because it is defined in here and we have to pass it in because it's required. So let's revert this again. And this is basically the big power of using intersection types in TypeScript. So the next concept on our list is the key-off operator. And before we start using it, let's first take a look at our interface we have here, which describes a device. It has an ID, manufacturer, model, price, and category property. And what we can do with the key-off operator here is to create a completely new type that automatically creates a new union type with all its properties. Let's see this in action here. Let's call our new type device props. And then simply using the keyOff keyword and the interface, we want to extract our properties out. And this basically creates, as I told you before, a new union type with all the properties as a string. So this is basically the same as this one here. Let's comment the first one out to remove our errors. And this is basically the same. So the result of this and the result of that definition here. But there is a slight problem with the second approach, and let's take a look at it. If we now want to manipulate or to edit our interface here by, let's say, removing the category because there are some changes in the definitions and we don't want to have this property anymore, we have to go into this definition here also and remove it. And as you can tell, this doesn't lead to very robust code. So when you are using the properties of an interface and want to work with them, I would highly suggest you to use the keyOff operator, because there all the updates or changes inside our interface gets recorded as well, and you don't have to edit your type definitions manually anymore. Now it's time for the typeOff operator in TypeScript. So it basically lets you extract a type of a certain value, which is either from a variable, for example, or the return type of a function. And let's take a look at first of a variable. So let's consider we have a variable called hello, and it has the string hello as its value. Now we can create a type which is called greeting, and we use now the typeOff operator and want to have the same type of the greeting as the variable hello. So we have to define the value type here. And now it's time to create another variable, which is greeting, and it has the type of greeting. And now when we hover over it, we see that all the declarations must be initialized. This is true because we have to give it a value. And this value here can only be whatever is here. So we can't define some gibberish right here. So we have to define exactly the hello string as mentioned above. And now we can take a look at our function right here, because this is typically a little bit more practical and more usual to make use of the typeOff operator. So let's imagine we have the following function here, which is called getMovie. It takes in an ID, and for now it's just returning a simple object right here, which is one of my favorite movies, by the way. And yeah, so it's nothing special right now. It's just a plain object with some properties, and we want to have a new type called movie, which is exactly the return type whatever this movie getMovie function returns. So we can specify it by the following. We create a new type, and then we are using one of TypeScript's utility types, which is the return type, that basically gets you access to whatever this function returns. And we want to use the typeOff operator and specify our function right here. And like in the keyOff operator, this line here is basically the same as like we would have defined it by hand, like this. Let's comment the first one out for now. And this leads basically to the same result. But like in the keyOff operator, this comes with a downside by defining it by hand, because when we are choosing to update our return object here, let's say by introducing a new genre property. For this case, it's martial arts. We would have to go into this type here and update it by hand. And as you can tell, like in the key-off operator, this wouldn't lead to any robust and more modular code. And when we comment this out, or let's remove it for now, and we hover here again over movie, it gets updated as well. So this is the more dynamic and modular approach. Now it's time for conditional types. So what they are and how we can use them. Basically, they are pretty much the same as in plain JavaScript when using the ternary operator. So you can evaluate a certain condition and react to this condition if it's true or not. So let's consider the following example right here. Let's say my var, and here we have a condition, let's say true, and then log it's true, and otherwise it's false. So this is basically the scaffold of a ternary expression. And the same concept is also being used in TypeScript using the conditional types. Let's jump in and see the example. So let's consider we have the following example where we have in our code an ID of something that is either a number or a string. And so let's first define our interfaces right here. So we have one interface that is called string ID that holds an ID property that is actually a string. And on the other hand, we have an interface called number ID that has an ID property that is a number. And the goal we want to achieve here through conditional types is that we have to define only one type that is called ID, and that gets evaluated if it's either a string ID or a number ID. And what we basically want to use is here the ID type as the following. So I comment it out first, and let's say we define a variable called ID1, and that is of type ID, and we just want to put in the actual type that this ID is by this. Of course, we receive an error right now because ID type is not defined. And on the other hand, we would like to do something like this. ID2 is of type number. And we want to have the ID to evaluate if whatever it receives, it evaluates through a conditional type if it has to use the interface string ID or the number ID. And this is where conditional types come into play. So let's comment it out first. And then we can take in a generic, which is by convention always called T. And then we can simply put in our condition T extends string. That means if T is a string, then we want to apply the string ID interface, and otherwise we want to use the number ID interface. And if we hover, this is called number ID. And when we hover now over our ID1, it should be of type string ID. And this is correct. And as you might have guessed, if we hover over ID2, it is from type a number ID because the type number doesn't extend the string. And we can use another example right here. Let's call it ID3. That is an ID. And we pass in a complete different type. Let's say an array of strings. And if we hover over it again, we see it's also from number ID because this condition here is also false. So to round this up, conditional types help you to create a more modular and type-safe code, and you put in some evaluation logic inside the type itself. And this makes it more reusable, as you might guess. All right, so the next concept on the list is infer type. And infer is a special keyword in TypeScript that lets you store something inside. So you can treat infer as var, let, or const you might know from JavaScript. So let's see an example to see this type in action. Okay, let's consider we have two arrays already in our code that look like this. And when you hover over the names array, so you can see that this is a type of string array, of course, and the ages array is a number array. And now we want to type some new types like the name and the type of age. But this shouldn't be something hard-coded like this or the age like this, because as we have seen before in other concepts, this is not very robust or modular, because when you are changing, for example, the ages here into strings, you have to go into the age type again and have to change it here as well. So we need something dynamic that extracts the type of the array, and this is where an infer type can be very helpful to us. So to accomplish this, we first define a helper type. Let's call this flatten array type, because that's basically what we are doing. And this takes in a generic, which will be our individual array type. Like for example here, if we put in the type of names, it will be a string array. And if we put in the type of the ages, it will be a number array. But as we can see further, this could also be something different, like any type we want to have here. And now, first, we will leverage the conditional type we have seen before. Let's first check if t is actually an array. And then we are using the infer keyword to store that type of the array inside our variable called array type, to use it further in our definition right here. So for example, if we take the names array right here, we can see it's a string array. And this array type will in this case be a string. And for the ages array, we have a number array. We will store the number type inside our array type variable right here. And if this is simply true, we want to return the array type. And if we put something different from an array, then we just simply return the actual type that is giving in here. And now we can edit our definitions right here to use this flatten array helper type. So let's use it right here. And then we simply use the type of names. And then for the ages, we will do the same, but with the type of ages right here. And now when we are hovering over the name type, we can simply see it's a string. And if we hover over the age type, we can see it's a number. But we can also put in a very different type, because in this case, the type will simply be returned. So let's consider we have another object right here that is called attributes and holds some different properties. And now we want to have a new type of attribute and also use the flatten array type right here and simply put in the type of attributes. And in this case, we don't have an array, and so this condition won't be true. And we will simply return whatever was put in here. And when we hover over attribute, you can see it's the exact type as defined here above. Now it's time for taking a look at map types. Map types let you transform certain types into new types. That's the reason why it's also called mapped, because you transform something. And they are very, very good to be used when you are creating utility types. And they basically let you perform any transformations of types you want to have. So let's see this in action. So let's take a look at the first example right here, where we have an interface called character that holds two different methods right now that don't return anything. And we would like to create a utility type called toFlags that transform all the properties to be a type of Boolean. And that's the reason why it's called toFlags. So let's first define our utility type right here, toFlags, that takes in a generic type. And then we can simply get access to all properties with the following property in key of t, and we want to transform this to a Boolean. And so this is the way we accomplish our wanted behavior. So we can now type a new type called character features, and we want to use it and simply put in our character right here. And now when we hover over this, we can see that all the properties, or the type of all properties, got transformed into a Boolean. And this is a very, very common use case for map type. But we have another example for you now, and let's see this in action. So, as we've seen before, we can transform our different types inside our properties, but we can do more with map types. We can also edit our access modifiers inside our interfaces. So let's take a look at the following interface, which has some properties right here, and they are all decorated with the read-only keyword here, which makes this character interface immutable. So you can only read the properties but not modify them. And we want to change this by defining a new utility type that strips all the read-only keywords array and makes the character or any interface we put in mutable again. So let's define our type right here. Let's call it mutable. That takes again in our generic. And then we first don't want to change anything. So we type in again property in key of t and just simply return the actual type of that property. And if we use it right now, so we can define a new type right here. Let's call it mutable character, because we make our character interface mutable. We can use our utility type and put in our character interface. And when we hover over it, you can see there's nothing changed. And here comes now the fun part, where we can tell our mutable type to strip out the read-only properties. And we can use it by doing the following. We can type in minus read-only, and this instructs TypeScript to strip all read-only keywords away from its properties. So when we hover over the mutable character now, we can see that all our properties are now mutable because the read-only keyword got stripped away. And of course, you can do it the other way around. So when you don't have any read-only properties right here, you can add them by typing in the plus. And when we hover over the mutable character now, you can see that all properties are decorated with a read-only keyword. So I think using map types is so much fun here in TypeScript, and it really makes a lot of sense and of course a lot of fun to use them inside your code. And to show it to you, we have also prepared another example where we have again a character interface that holds all required properties right now. And we can also define a new utility type called optional that makes all properties in here optional. So let's first define our utility type right here, optional. That takes in again our generic type T. And for now, we don't want to change anything again. Just simply doing no transformation right now. So we have to type it out first. And great. So let's use this first. Let's call another type optional character that actually uses our optional utility type and takes in the character. And when we hover over it right now, you can see there's nothing changed, and we will want to use this right now. So how can we make all our properties optional? So as you might know, an optional property in TypeScript is defined by putting in a question mark behind it. And in our map type, we can also do this by simply typing in a plus and a question mark. And this instructs TypeScript to add this sign right here. And if we hover over it now, you can see that all our properties are now optional. And because they are optional, they can also be undefined. And again, like in the example before, this also works with the other way around. So when we have optional properties right here, let's only make the first one optional. And we can define a new type right here. Let's call it required type. This also takes in a generic. And for the sake of this tutorial, I will copy this right now. And now we don't want to add the question mark, but remove it. And if we use it now, let's call this required character and use the required type and put in our character, we can see that all optional properties are gone. One quick note right here. Of course, as you might know, they are also built-in utility types that let you accomplish our example right here. So this is for the one side, the partial utility type. And as you can see, it also makes all properties optional. And for the other one, it's the required utility type that makes all optional properties required. But for the sake of this tutorial, I would like to show you the map types right here. And I think it's a really good thing to know how you can add or remove certain modifiers or certain keywords inside your map types. So have fun with it. That's it. We made it through. Thanks for watching, and I hope you enjoyed this video. If you want to master more complexities of coding, then smash that like button and subscribe to this channel to stay up to date. If you got more questions, drop a comment and I will answer them all. See you next time, and happy coding!